I'm Roger, and in this video we're going to talk about extension cords. Fixing them, the right way to fix them, what the parts are called properly, and what kind of cords to use and not to use, and what types of cords you should cut the ends off of and throw away. Coming up. One time or another, everybody needs an extension cord, and you need to be safe about it. Obviously, if you're working out in your shop or you're out in your garage or whatever, you definitely need to have ground fault circuit protection. GFCI, GFI, it's all the same type of thing. Ground fault interrupter. If you watched any of my previous videos, you may know that I'm a retired electrician. I have over 40 years in the trade and an immense amount of experience in the industrial environment and working with cords. And also on construction sites. I mean, all you guys out there, whether you be a carpenter, a painter, a plumber, or whatever, you're going to have to deal with an extension cord. There's certain types of cords you don't want to use. If you have to have one of the old, I don't even have an example to show, they were flat, either yellow or orange, and you can get them 25 feet, 50 feet, 100 feet, and if you nicked them, you were right into the conductor. Those are not permitted on a construction site that could be inspected by OSHA. If they come on a site and find one of those, the contractor that owns that's going to get a pretty stiff fine. Another little thing that was popular for a long time is this. Take a cord, put a box on it. If you're on an OSHA site, don't do this. This particular one here, I'll use it for an example with the type of cord. You can see it's all gnarled up. It's nasty. And there's a sticker on the side right here. And I got this at an auction with a bunch of stuff. If you've ever been to an estate auction and they start bidding on stuff and it doesn't go up high enough, they start throwing a bunch of crap in there trying to get people to buy it. So you end up with a bunch of junk. Well, this is some of that junk. But it's got a good box on it. It's got a good cover on it. And with these green dots, these are hospital grade receptacles. So yeah, that's a good deal. But this isn't legal. You can't do this anymore. The sticker on the side came from, well, I won't say where it came from, but it was inspected. Someone had to inspect this, and it was last inspected on May 3rd of 1984. Hence, it's old, it's been around, it needs to be taken apart, and this part of it thrown away. Next are cord types. There's different types of cord, whether it be your just household light duty cord. There's, if I get into all the technical parts of it, you're not really going to understand, but for example, this old cord here on this thing, this is type SJ. It's a light duty cord. Just, you know, it's not for any kind of heavy use. And it looks like it actually originally came off of some type of appliance or something. Next up is SO cord. Here's a piece of that right here, one end on it. I'm just using this for an example. This is a more of a outdoor heavy-duty type, and there are a plethora of different types of outdoor cords. Then you get into the hard usage cord, which is what I'm going to be making a cord out of here later. This is a piece of SCOW, hard usage cord. It's industrial. It's a 12-3, 12-gauge wire. I'm going to use it for making a little extra extension cord for my planer because I can't always get it right where I want it, but I don't need it real long. So you also want heavy duty for that. If it's telling you in your manual for whatever tool you have to use a 14-3, 12-3, even a 10-3 cord, follow the directions. Don't go light on the cord because you will underpower the machine. Next we'll come to, obviously this is a 3 conductor. It's got an old end on it. I'm going to be cutting that off. There are some 2 conductor cords out there, and I've got one here. Yeah, neat. So here it is, 2 conductor. Well, it looks like it's about 50 feet long. The end's getting kind of gnarled up here. It's pulled out of the connector, or the female portion of the cord. There's no ground on this. Here's something else. If you're on a construction site where OSHA is going to be around, you better not have one of these laying around. And not even laying around. You don't have to have it in use. Just don't even have it there. Get it off the site. And what I'm going to be doing with this is another one of them little auction goodies. I'll be cutting the ends off of this and throwing it away. And here's what someone done. Hopefully you can see that. Originally it had these little plastic blocks on there so you couldn't plug a grounded plug into it. Well, somebody must have needed to use this with a grounded plug, so they cut that off so they could do that. There again, if you're on a construction site, you damn sure don't want to do that, nor do you want to have a cord with that ground prong missing. That was always one of the big things on construction sites. Inspectors will go around looking at your cords to make sure that they were complete. And some sites I've been on, in fact a lot of the industrial sites, your cords are actually inspected once a month. And it could be with different colored tape, it could be with a number on it, and they log it in a book. It's very important that, especially the big contractors where OSHA is going to be around and really watching you, is you keep track of your stuff and keep everything in a safe condition. Next, we're going to talk about the cord parts. Obviously, this part here, that's the cord. A wire, whichever you want to call it. But what a lot of people do is this part here, they'll call that the plug. That's not a plug. This is a plug, spark plug. There's pipe plugs, that type of thing. This is not a plug. This is a cord cap. The other end, the female end, that is called a cord body. That's not a plug either. Nor is where you plug it in. That's called a receptacle or an outlet. And there's also different patterns. What you see here is a 20 amp 250 volt. So you can't plug your 15 amp 120 volt cord cap into it. Well, you'd burn up whatever you're doing. Well, then you get into patterns on the other end, and you'll see here one's straight and one's 90-degree angle, but they're opposite of each other. This one over here is a 20 amp 120 volt. This is a 20 amp 250 volt. So this one will fit there in that receptacle. This one will not. As you can see, there's just no way that's going to work. So it's important to know those, and if you're working with, for example, maybe an air compressor or something like that, you need to make a cord for it, make sure that you get the correct pattern. The other thing, and I've seen people do this, is take one of these regular receptacles for 120 volts and wire it for 240 volts, thinking, well, I'll just have this one just for this outlet. Well, someone else may come along sometime and not know that. And then they're going to plug something in and boom, whatever they plugged in, they just burned up. And then the phone could ring. Okay, now after that operation, where was I? Oh yeah, I was kind of harping on safety and using the correct cord pattern for what you were doing. The same thing goes with maybe your household dryer or your stove. They're not going to have the same plug. They're going to have different patterns. Perhaps you have a generator that has to have a particular type of connector on it. Maybe it's a twist lock. For example, my table saw here has a very special setup, which I'll get into on the table saw video I'm going to do here shortly in the future. But it's fed with a 4-wire, very heavy-duty SCOW cord, 10 gauge, with a twist lock connector on the end and a twist lock receptacle under the panel. And I'll go into all that and why I did it that way when I do the table saw video. But getting back to these cords, yeah, I'm harping on safety here and everything, and there's a good reason for it. Being that many years in the trade and that many years on construction sites and in industrial environments, I've seen some accidents that really shouldn't have happened. One prime example would be, I was working on the roof of a building, and they had a painter up there with a scaffold set up. It's on a metal building, and his cord got cut in two. So instead of having one of us electricians fix his cord, he did it himself. Well, as we're going to get into when I'm showing you how to wire a cord and put cord ends on, he got the green and the black mixed up. Well, the green's ground, the black's hot. He put the black, which is the hot, on the ground terminal of his cord end, cord body in this case, and the green where the hot should have been. So when he got on there and plugged on his tool and went to climb up that ladder, Fortunately, it was ground fault protected because it instantly tripped that ground fault interrupter. If it had not been ground fault interrupted, there's a very good chance he would have been electrocuted. So, you know, this isn't a place to play around, and I'm not going to do a whole lot of electrical how-to videos because there is some liability there. Like, I'm not going to tell you how to wire your house. I'm not going to tell you how to wire your shop. I may bring up a lot of things not to do, but I'm not going to go into details because somebody could come back and sue me because they did something stupid. What I'm going to do here with the cords is pretty basic. And while I'm talking about making a cord, because I'm making a special purpose one here, you can buy those. You can go out and buy a 20 amp, 250 volt cord, and it would probably be cheaper than if you bought the components. If you start looking at the costs, and you may not be able to get these as cheap as I do, but this 20 amp, 250 volt cord cap is around 10 bucks. The a cord body, yeah, you're probably looking for a good one like this around $15 or $20, depending on where you go. I can get them for about 10. But then you got to buy the cord or buy the wire. So if you start looking at wire, which is, you know, you get into 12.3 SCEO W cord, some of that might be $1.50, $2 a foot. Well, now you start adding that up, and you compare the costs, not counting the labor of what it's going to take you to put it together. But a lot of times it's cheaper to just go buy a cord already made. In fact, there's been times when I've needed special purpose cords and I needed that 12.3 extra heavy duty wire. I'll just buy a cord off the shelf, cut the ends off, and put my 250 volt ends on it. And I always make sure that both ends are 250 volt ends and not one in 120 and one 250. And you may hear me say 250, 240, 220. You may have heard the joke, 220, 221, whatever it takes. Household voltage in your house or in your shop, unless you have a commercial shop and have three-phase electricity, you have three legs coming in. One leg is 120 volts, the other one's 120 volts, and the third leg is the neutral. If you take the opposite 120 volt legs and you put them together, obviously not together like this, but in a circuit, you'll have 220, 240, whatever you want to call it. In the trade, it's 240 volt, nominal voltage. It may not actually be 240, maybe a little bit less. It's like your standard outlet. You plug stuff into the wall. Some people say 110, some say 115, some say 120. I always call it 120. The nominal voltage is usually about 117, depending on where you are at in the country, or if you're in another country. For example, I got a Cozumel shirt on today. The nominal voltage down there is usually 114, 115, and you can find some interesting wiring practices down there. But all that said, here, let me get some stuff together, and I'll show you how to properly put an end on a cord. I want to start out first talking about what do you do if your cord's got a nick in it. You know what? You can see this cord, of course this is a piece, but you know, so you're checking your cord, and something you should do from time to time with your cords, and I'll use a piece of this as an example, is start at one end and run your hand along the cord down the entire length, looking for, obviously unplug it first, and look for anything, any abrasions, cuts, nicks, that type of thing. So if you do need to do a repair, you don't find out you need to do it the hard way. I know there's been a couple times over the years where I've been rolling a cord up, it was still plugged in at the other end, and found a bad spot. And yeah, I got shocked a few times. It's no fun. So if you got a cord here, but it's got a nick in it, so what do you do? You know, oh, it even got in, of course it's a green conductor, but it even got into the conductor. So what's a lot of people's first instinct? Roll of tape. Don't do that. If you're on a construction site where OSHA's going to be, and I'm not a big OSHA proponent, but they have some good rules for a reason. Don't just tape it up and keep using it. OSHA finds that, you're going to have a fine. That cord needs to be cut and either thrown away or new ends properly put on each side. Then you have two cords. But anyway, don't just tape up a nick on a cord. That's a bad thing to do. Next thing I want to talk a little bit about our tools. These are not brand new. They came off another cord, but they're perfectly serviceable. Everything on here is going to be a Phillips. So I have a Phillips screwdriver. I will need wire cutters. I happen to have a pair of, we call these dikes in the trade, but they're diagonal cutters. These happen to be made by Klein. Then you're going to need the wire strippers. Something a lot of people don't know, especially with, at least with Klein tools, if strippers have yellow handles, they're for solid wire. If they have red handles, as these here do, they're for stranded wire. A lot of people don't know that, but good little thing to know. Then you want to have the right size stripper for the right size wire. This one here goes from number 14 to number 8. This one here is for number 26 and number 16. Actually, in the last several years, I was in the electrical trade. Since I worked on high voltage relaying and instrumentation, I use these more than I ever use these. I used to hate to see a piece of wire if it was bigger than number 16, but that was just kind of a running joke between us electricians. Okay, we'll get into exactly how you do this. There's my two ends of that I'm going to put on. Here are my two ends of the wire. Something a lot of people don't know is this belongs on one end and the other one belongs on the other end, but they don't swap. The reason is the conductors, as they come out of the cord, will perfectly fit and perfectly match, and you won't have to cross a conductor over. If you're building a cord and you have to cross the black and the white, you've got the wrong end of the cord. You need to grab the other end and put that particular, either whether it be a cord body or cord cap, on the other end. So let me get a knife here and I'll take these apart and we'll get ready to build the cord. After you have your cord end components taken apart, this here is the cord cap, the male portion. You'll notice that there's a silver screw, a brass screw, and a green screw. The silver screw is always white, neutral. The brass screw is always black, your hot line. And the green screw is always ground. There are no exceptions. That's the way it is. It has to be that way. If you start mixing them up, as I told you earlier with the painter, you could really get hurt or possibly kill somebody. So the first thing you're going to want to do is strip the outer jacket off of the wire. I'll just grab an end here. And I'm going to do something that if you do it this way, be careful. I've done this for years. Now you don't want to strip a whole ton back because you don't want it hanging out here. Ideally you want the outer sheath to almost meet up with the plastic base here, to let the grip down here grip as much of the outer jacket as it can. So I'm going to come back here about 1 1/4 inches. And what I do is I score around the outside with a knife. Like I said, I'm highly experienced at this. And I check to make sure I didn't go too far, and I did not. And this being SCEO cord, this is going to be hard to strip. Then once you get through the jacket, and this stuff is really tough. I'm surprised. I usually hit this on the first shot. What you don't want to do is cut too deep and get into the conductor. Because if you do, you're going to have to cut the end off, start over. So you want to do a little bit at a time. And once you get to where you can start to see the inner conductors, if you push real hard both ways, that rubber will tear. If you're working with SO cord or SOW cord, it won't be near this hard. This stuff can be a stinker to work with. But I had it and I wanted to use it for this because it's going to have some hard usage. If you're using SO cord or SOW cord, once you get scored like that and you get the opening, as you see here, this piece will just slide right off. With this heavy duty cord, it won't. So I need to slice it. So now you're going to see that there's a braid and some plastic sheeting and sheathing around the outside of the conductors. As I said, this is on an especially hard use industrial cord. You're not going to have this on your regular SO cord. There's some cellophane and there's some little burlap looking like fiber fillers. So you want to get all those on around. You want to cut those off. Make it all nice and pretty around there. And you can unwind your conductors. So, you see here, it's my ground, my neutral, there's the hot. So you want to have the right end. I didn't look to see which end I was grabbing, but since the neutral's on the right, now that's going to be the cord body. There we go. That way when the everything goes in, and I'll try to hold this up so you can see, the ground's going to be there. There's the hot, there's the neutral. You look, there's the brass screw, the silver screw, and the green screw. The next thing you need to do is not be stupid and forget to put the back shell on first, and now I've got them mixed up so I don't know which one's which. Okay, this one goes with the cord body. And this is going to be a tight fit considering that's number 12 in there. Back these screws out a little more. There we go. Yeah, don't forget to put that on first, because otherwise you're going to go back to put the, you'll put the end on and then you're like, oh crap, and you'll be taking the end back off. Or sliding it all the way on from the other end if the other end's still open. Okay, next thing you're going to want to do is strip that wire, but you only want to strip it long enough to go into the body here. You don't want a bunch of bare conductor hanging out behind it. Get on to number 12 here. And that's about a 1/2 inch. That's what most of them are on these heavy industrial commercial plugs like this. Next thing you're going to want to do is give them all a twist. Make sure you don't have any little strands hanging out anywhere where they're not supposed to be. Then you line everything up. Make sure your screws are all backed out 100%. Get it turned around like it's supposed to be. Start with the ground. You just work them in a little bit. Form the wire as you go to get it into the right hole. Then when everything's pushed in, and I haven't tightened these up yet, but I want to show you how this looks. No bare wire hanging out. No insulation going underneath the little clamps inside either. And a minimum amount of wire out the back. From there, just tighten them up. I like to keep a constant pressure on the back so that nothing slips out. And then the ground. Next thing is to slide the shell up to the body, and in this particular case there's a little nub that sticks out here. There's a little recess. It's generally right above the ground screw. It's pretty easy to find. Just line those up. Tighten your body screws down in. Screwdriver's a little big for these, but it still fits. And don't forget to tighten your clamp. And as you can see, there are no conductors hanging out the back of the cord. Whoop, there's no conductors hanging out the back of the cord. I've seen many times where people do this and the outer sheath is clear back here. You don't want to have that. You want to make sure everything's covered. And you want to tighten the clamp down securely. Sometimes if you have a big cord, there'll be a little insert in the back of the clamp that you can take out to be able to accommodate that large cord. There we have it. There's the female end. And I'll just repeat the same thing on the other end. And it's the same process. I don't need to necessarily show that again, but it'll be identical, same process. Okay, and here's the finished product. It got me a nice little 20-foot cord to under my planer. I have to drag it outside, and I have to do that once in a while if I'm planing something that's long, really long. I pretty much have to do it outdoors, so I don't have enough room in the small shop. The other point with doing it outdoors is I can blow the chips right into a wagon. I don't have to use my chip collector. At any rate, yeah, I harp quite a bit about safety and extension cords. I've seen a lot of things over the years, as I've mentioned. About the last 25 years of my career, in the electrical trade, I worked in medium and high voltage. And when I say medium and high voltage, 480 isn't high voltage. That's low voltage to us. I work with things 4,160 volts, 13,800, 14,100, and up to 35,000. No, you don't work that hot, but you make damn sure that crap's off before you touch anything. And there's a lot of specialized equipment for it, and it's going to be way beyond the scope of anything you people mostly will understand. But one other thing I wanted to mention was with extension cords, while we're on the subject of safety, don't bury cords. I've got a video, I'll link it here at the end, of a friend who, well, he still owes me for this favor too. But someone for his shed had buried a cord. And if you watch that video, you'll see what happened. And it wasn't good, especially for the time of year it happened. He was roasting out there. Anyway, if you got anything out of this, appreciate getting a thumbs up. Of course, comments are always welcome, and I'll probably rouse a few people up with my OSHA comments. And maybe you don't like my method of wiring, but that's the way I've done it. I'm a master electrician. I have never had a failure with any of these connections, ever. So I know they work. Otherwise, we're always looking for subscribers. And until the next video, thanks for watching.